Okay. So my intent is to not necessarily go through the whole thing, just the ones you guys are really super struggling with and need help on. So you guys tell me, what do you want to go over? There was one, actually, let's start with it was item 4, right? That we had. I probably messed up when I was writing this, so that's item 1. This one's item 2. The stupid thing doesn't number it when you spit it out, so 3, 5, 6, 7. And I may narrow it down from this, okay? This is just, if you know these, it's probably going to go okay. All right. So let's take a look at, let's start with item 4, and then we will look at it from there, okay? I am not going to regulate which ones you use your graphing calculator on or which ones you don't. Just know that when it comes time for the actual AP test, there's a difference and you won't be able to use your calculator on absolutely everything, okay? So on this one right here, when we look at it, if I just were to draw just a sloppy sketch, okay? I know that e to the x kind of looks like this, right? So that's e to the x. X equals 0 is this. And x equals 1/2. I don't know, it's somewhere in here. And then we're supposed to be about the line y equals 5. So somewhere up here is y equals 5. And this is what we're supposed to be revolving around. It's not clear from the information I gave you whether I intended for you to use this region or this region, okay? It looks like from my answer that, actually it is clear. I think I was wrong, Carlos, yesterday. Because no, it wasn't, because I should have also included the line. Okay, I needed to include one more line. So it isn't, whatchamacallit, it isn't clear from what I wrote, okay? But I'm looking at my answer choice, and it looks like I intended it to be a disc, not a washer, okay? So it wasn't the axis that was included. It was supposed to be, let's gonna erase some of that. It looks like it should have been this. So I missed typing in there that y equals 5 should have also been in here. Does that make sense? Am I clear now on where I wanted it to be? So the answer is correct. It's just what I included to make that answer correct wasn't quite there as much as what it should have been.
The y equals 5 is on this.
Yes, but that's only the axis of rotation. It doesn't tell you it's a bound. Okay, does that make sense? So I had good intentions. I had the right region in mind. It's just I did, because if I said it was 0, right? If I, instead of writing y equals 0 there, if I had written, or if I'd written this, then it would have been this region, and now it's a washer. Okay, does that make sense? Okay, so it was there, but it wasn't there. Okay, and that was my fault. That's what happens when you do these things at 4 o'clock in the morning and the baby wakes up, right? And interrupts your work. Okay. So whenever we do volume, what do we always, well, whenever we do volume of a rotation or revolution, what do we start with? Pi. Good. All right. Bounds were nice and obvious. What were the bounds? 0 to 1/2. Okay. When I am doing so this is a disc because my shading there is touching my axis of rotation. Okay. So I know that that's a disc, which means I only have one thing squared. Okay. All right. What is the top curve then? Yeah, the 5. So I'm going to go 5 minus, and then the bottom curve is what? E to the x. Okay, so that should hopefully make sense on, I don't know why. Oh, it might force extra parentheses or something with the dx maybe. I can't remember what it does. Okay. All right, so hopefully that clears that one up because that was my fault. All right, you guys pick whatever else you want. So what else do you guys want to do? 3? Okay, let's go back and look at 3. Write but don't integrate a definite integral that computes the volume of a solid generated when revolving the region bounded by the graph of y equals x squared and the line y equals x between x equals 0 and x equals 1. It's definitely indicating that we're going in the y direction, right? Because it said we're revolving about, where did it say? Oh, the y-axis right here, okay? So I'm going to start by drawing myself a little picture, okay? There's good news and bad news. The good news is that my equations are y equals, which that's really easy to draw, right? I know y equals x squared. It's going to be a parabola, probably half of it that looks like that because I'm only in quadrant 1 because I'm in between 0 and 1. And then this is a line. The line is going to be, the line is typically above. So it's just this little tiny region right in here. That's what we're revolving. Okay. And I believe that they cross, right? We could put that into, we could say x squared equals x. So x squared minus x equals 0. Take out my x equals 0, and x equals 1. So I know that this is crossing at 0, and I know this one is crossing at 1. Makes sense for what they gave me, okay? All right. The problem is that we have to revolve around the y-axis, okay? So what that means is my equations have to be in terms of y, and I need to do a right minus a left, okay? It also means that I'm going to need the y values, not the x values. The good news is they're kind of the same. But... All right, so before I try to get it into my formula, what am I going to have? What do I have to do to this one here to solve it for x? Yeah, we're going to square root, and technically, when we square root, we get a plus minus. But because we're in that positive quadrant, we're just going to use the plus. So it's just going to be square root of x. And this one's already done, isn't it? How nice is that? Just write it x equals y. Not a big deal. And I wrote this wrong on the picture, didn't I? That's supposed to be a y. Let me try that again. Erase just this. Okay. Supposed to be square root of y. Okay. So when I do a volume of revolution, how do I start? Pi. Good. Okay. Now, I've got to have y bounds. I got to go from here to here. Definitely starts at 0. Okay. I know that my x value is 1. I plug it into here, and lo and behold, it's also 1. So I kind of get away with those being the same. Don't count on it, though. Always check it. Maybe I won't be so nice, or the AP exam won't be so nice. Okay. All right. I want my right curve. What curve is on my right? Okay, remember I have to be in terms of y. Square root of y. So square root of y minus, okay. Oh, wait a minute. I'm doing a washer, aren't I? Let's rethink that again really quick. So it's got to be my outer minus my inner squared, okay. And then I'm going to do right minus left, but my right minus left is the curve minus my axis of rotation, okay. So my curve, my outer, which one's my outer? My square root of y or my y? Square root of y has got to be my outer, right? And then this is on the right in there, and this is on the left. So I know it's kind of a pain, but it's easy. It hopefully follows a good pattern. So it's going to be square root of y minus 0. My inner is the y, and I'm going to subtract. So my inner to the left, or sorry, inner right, it's minus this left is going to be 0. Do I really need the minus zeros? No. Okay. And hopefully you can kind of see, look at what my answer did. It's square. I put in the most simplified answer. Okay. Could you type that in tomorrow and I give you full credit for it? 100%. Okay. I didn't work very hard when I was putting my answer choices in. I just went all the way simplified. Okay. All right. So pi between 0 and 1. I ignore my 0. Square root of y squared is just y. And then y squared would be y squared dy. And typically we put parentheses around those. Okay. Hopefully that one's a little bit better. I am going to give you one, either an area one or a volume one, that does go in the y direction versus the x, just to make sure you can do it. Okay. The 0, it's your axis of revolution. So, because sometimes it's shifted and sometimes it's 0, right? So it's just a good habit to just always write it. Okay. So you don't have to write it, but it wouldn't be wrong if you didn't. But it's just a good habit to get in. So then you know when you're doing a washer, you have your outer and your right minus left or top minus bottom. You do your inner, your right minus left or top minus bottom. Okay. All right. Any other questions on that one? All right. What else would we like to see? 6? Okay. Let's look at 6. Is that the right one?
Yeah.
Okay. So a vase has a shape obtained by revolving the curve y equals 3 minus cosine x from 0 to 4 about the x-axis, where x and y are measured in inches. What is the volume in cubic inches of the vase? Okay, so to do volume of a revolution, how do I start that? Pi, and then what are my bounds? 0 to 4. I should probably go look. I know it's going to be something squared probably, but I should go look and make sure that at my curve, just to make sure there's nothing goofy going. There's only one curve. Okay, so probably it's fine. But I should look at it really quick. Okay, so let's get that into your calculator. Let's practice that part. And again, on our test, I would, even though I give you, sorry, this one's been flying around and bugging me. Oh, good, we got another one too. Caught like 2 up there today. All right, there we go. I would use your graphing calculator. Double check to make sure your mode is in radians over the Desmos, even though Desmos is embedded into the quiz. Okay, it's just that's your little indicator. Hey, it's a graphing calculator problem. All right, 3 minus cosine x. 3 minus cosine x. Oh, I'm missing parentheses. You can't just type cosine. It's better to use the trig button. I forget sometimes. Okay. And if it helps you, you could zoom in on the, whatchamacallit, the 0 to menu, Windows Zoom. I'm going to just go -1 to like 5. All right, so the curve that I want is like somewhere in here. That's what I'm looking at. I don't know if it'll let me copy it like I used to be able to. Paste. Ooh, there it is. But it's nowhere near where I want it, huh? I just wanted to be able to scribble on it for a minute. Oh well, we're going to leave it there. Okay, so I know 0 to 4 is somewhere in here. It definitely looks like our region is touching our axis of revolution, which is supposed to be the x-axis. So it is revolving around that and making a vase-like shape. So I just need to put it into, so it's 3 minus cosine x. So just the way it looks. Since that's already in F1, we could just say F1 in our calculators. So that one you do need to go back to the calculator page to do, though. Which is why it's important that you understand how to do it off the calculator page, because your volumes you can't just do off the graph. You do area off the graph, not volume. All right, remember pi is next to the H button. So pi, how do I get the integral? Shift plus, we said 0, not 0, what was it? Yep, 0 to 4. And then you want to use parentheses because you're going to have to square it. So var F1 of x, go outside both parentheses, square it, dx. Three decimal places. Make sure you're writing down 3. When I was grading the 8.1, there were some of you that weren't writing down 3. Okay, and again, that's another good reason to use the Desmos or use the calculator over Desmos, because we know we've got it set to the right number in there.
So this one was a revolution?
This one was a revolution still, yeah. But it was a revolution around the, see how it says x-axis? So I was revolving, where's my picture again? I was revolving this way, okay? And my axis of revolution was touching my area, so we're good for a disk. Okay? All right. What else do you all want to do? 5. Okay, let's go back and look at 5. All right, write but don't integrate. The expression for the area bounded by the graphs of x equals 1/2 y cubed and x equals 3y in the first quadrant. Okay. A little bit more challenging to figure out what that is, right? Here's where Desmos would actually probably give you the advantage, right? Because you can actually in Desmos type that in the way it looks, right? And it's going to give you a graph. So I guess my Christmas gift will be, let's use Desmos on this one, okay? And see what happens. We could, put this in our regular calculator, you could do, whatchamacallit, you could just solve it for y, okay? So let's put it into Desmos, and I'll show you, because this was just write but do not integrate, right? Yeah, okay. All right, so let's get Desmos going. All right, so x equals, I've totally forgotten the problem, 1/2 y cubed. Okay. And x equals 3y. The nice thing is they gave it to you, so you didn't actually have to solve it, but we did need to figure out like our points of intersection and stuff, and which one's on the right and which one's on the left. So Desmos is nice in the fact that it's really easy to get the points of intersection, because that's definitely the point of intersection right there. I'm going to grab this really quick. It's not going to let me keep my point of intersection, but that's okay. All right. I'm going to see if it'll let me put it out on this edge. Okay. So there's our graph. Okay. Our point of intersection is at 2.449. And again, if we had to do it by hand, we would take these two things and set them equal to each other and calculate our point of intersection, okay? Which we would want to move the 3y to the same side and do some factoring, okay, to do that. All right, all I literally need to do is just write the integral. So I feel like I'm missing something else. It says, it's just an area problem. So do I need a pi out front for an area problem? No, okay. All right, so the integral, what? If I'm going in the y direction, so I'm supposed to be going like this, what are my bounds going to be? Yeah, I only wrote down the y value, huh? The x value was 7.3 something, so you only write down the y value, so 2.449. Yeah. How do I know it's what? How do we know if it's revolving or not?
So it's not revolving?
No, because it says that it's area.
So why did you use the y value?
Because it was already set up for y's. Does that make sense? It could be. We could do it that way. I guess you could go back. I probably should have put in there perpendicular. So I probably missed some words. Perpendicular. You know that. Never mind. I'll write out the word. It's been a while since we've said that. Perpendicular to the y-axis. So if you saw that word in there, you're forced to do it in y. Does that make sense? Okay, it's probably my fault for missing the words. I think if you had probably tried to solve that for x, it would have been pretty ugly, right? So it's actually probably easier and cleaner to make it look like y's. All right, so which one is on the right? Yep, so I'm going to start with 3y, and then I'm going to subtract what's on the left. Good, and then throw a dy after it. No squaring or anything. It's just that. All right. What else do you guys want to talk about? Number 7. Okay. We've got the base of a loudspeaker system determined by the curves x squared over 20 and negative x squared over 20 for between 1 and 4 as shown in the figure to the left. For this loudspeaker, the cross sections perpendicular to the x-axis are squares. What is the volume of this speaker in cubic units? So again, I let you have your calculator for it. So let's put that into our calculator. Why don't we do that? So we're going to put them in as 2 separate equations. So I think it was x squared over 20. X squared over 20. And divide negative x squared over 20. I don't see the real need to do any zooming because, again, that would be, you're kind of wasting time, right? Because we don't really need the graph other than to know maybe which one's top and which one's bottom. We can get that enough from that picture there. Okay. So we have to figure out the length of a side. Okay. So which curve was on the top? The x squared, the positive one or the negative one? The positive. So the top is x squared over 20. The bottom is negative x squared over 20. So the length of our side is going to be the top curve minus the bottom curve. What happens with the double negative? It goes positive. So we really have 2x squared over 20. Or if you wanted to reduce it, it could be x squared over 10. Or you could just literally type this, which is really f1 minus f minus f2, right? So your choice on how you do it, since it is a calculator problem. Okay. If we were going to write out our work, we would probably just use this. Okay, so we're going to integrate. Where are we going to integrate to and from? Do I need a pi out front this time? Are we revolving it? No. Okay. What's the formula for area of a square? Side squared. So I'm going to literally take my side that I got, 10, and square it. Or I can write x squared over 20 minus negative x squared over 20 in here. Both of those are fine. Okay. All right, we're going to use our calculator to do everything else for us. So I'm going to go back to my calculator page. Shift plus. Go from, was it 0 to 4? 1 to 4. 1 to 4. And then we're going to do, it was in F1 of X. And the reason to not type it again, or not even type what you wrote down and maybe calculated by hand, is because you might make a mistake. If we've already got it in there once, and I need to put a squared on this, there's no point in opening ourselves up for error. Okay. We good on that one? What else do we want to talk about?
I think 8, but I need the last 3 seconds, so we can do a whole thing.
Does anybody need the whole thing on 8? Yes? Okay. Okay, let's look at 8. Again, you get to have your calculator on this one. But they were nice enough to give us a picture. Okay. And I purposely threw some things in here because I was just trying to get it all in. And so I threw some extra cross sections in here. So we made sure we covered all the cross sections I might put on the quiz. So we had a square. I think there's an equilateral triangle and a semicircle hidden in here. Okay. So be ready for at least those 3, meaning you need to memorize the equilateral triangle formula. Okay. I'll be nice and not put the weird isosceles with weird bases on. Okay. All right. So the region S is shown above. S is bounded by the graphs of f of x equals square root of x and the x-axis, and x equals 1 and x equals 4. Okay, so we're just supposed to find the area of the region S. So literally, I'm going to integrate. Where am I going to integrate to and from? 1 to 4. What's my top? What's this equation? That's square root of x. Okay, what's my bottom? It's 0, right? And then dx. All right, let's put that into, I'm going to go back to my graphing calculator and put that in. Okay. Should really have that. Okay, back to this guy. Yeah. What do you mean? They did give us the other one. It's the x-axis.
Oh, okay.
I was good on that one. That number 4, I blew it. Okay, but this time I was good.
Okay.
Probably because I copied it from somewhere and I was making up number 4 on the fly. Okay. All right. So I'm back in here. I'm going to do square root of x. And hit enter. And then we're going to integrate from, so I'm just going to, and I could do this off the graphing calculator page, couldn't I? If I really wanted to, I could. I'm going to choose not to, but I could. So shift plus, I think it was 1 to 4, right? 1 to 4. So 1 to 4. This one actually probably wouldn't be too bad to do by hand. And then it was square root of x. I really don't need to worry about the 0 dx. And there's our value, 4.666 or 4.667. All right, we good with that part? All right, region S is the base of a solid. For each solid, the cross-section perpendicular to the x-axis. See, that was the words I was missing in the other one, right? So perpendicular to the x-axis means that my cross-section is going like this. That's how you know you're going to use x's instead of y's. If it says perpendicular to the y-axis, I'm going in the other direction, okay? All right, write but do not evaluate the integral expression that would compute the volume of the solid. So to get the side length on this one, because that's the kind of the first thing I need, is I need that side length. What's my top curve? Square root of x. What's my bottom curve? 0. So it's square root of x minus 0, just square root of x. Okay. That doesn't mean on the quiz I might not give you another equation there. I could. Okay, that's fair game. All right, so we need the formula for an equilateral triangle. What's the formula for equilateral triangle? Square root of 3 over 4 x squared. Good. Area almost always has something to do with squared, right? So it's a safe bet that you're probably going to square something. All right, so we're integrating. I'm going to throw the square root of 3 over 4 out front as a coefficient. We're still using the 1 to 4 bounds like we had before. I'm going to take this, throw it in there, square root of x squared. I typed the simplified answer. Both are correct on the quiz. Okay. All right. Let's take a look at the next part of it. Region S is rotated about the line y equals -3. Right, but do not evaluate an integral expression that would compute the volume of the solid. So I'm going to go back and look at my picture a little bit. Y equals -3 is going to be down here somewhere, right? That's my axis of revolution. Do I have a disk situation or a washer situation? It's a washer, okay? But notice I still have an inner and an outer, don't I? The top curve is now becoming my outer curve, and the x-axis is becoming the inner curve, which is weird on this one. Sometimes it's easier to have a different number other than 0 because we're looking for it. Okay, so let's see if we can write it. We know that when I do a revolution, what do I start with? Pi. Okay, what are my bounds going to be? 1 to 4. That didn't change, right? All right, then I am going to do outer squared minus inner squared, and we're using dx's. Okay, which function was my outer? Square root of x. So if I'm looking at that, so but this is also my top minus this bottom right here. Does everybody see the top and the bottom? Okay, so I've got to do square root of x minus -3. Instead of minus -3, what else could I write? +3. Okay, that part's not so bad. The next part is where it gets kind of weird. Okay, so my inner curve is 0, and I've got to do this top minus this bottom. Okay, so let's try that. My outer curve is 0 minus my, which is the top, minus my axis of revolution. Again, it's going to be +3. Not that it matters because we're squaring. And I wrote the simplified answer. I didn't bother foiling or anything, but I'm not that ambitious. But all right, minus, and then 3 squared is 9. So do we understand why it was just a 9 now, hopefully? Because I did some arithmetic there, I guess, and then technically parentheses around the whole thing. You can leave it in the first line. It's fine. You can leave it minus, and I will take it. Okay. Okay, you ready for perimeter? Okay, so we didn't really go over a lot of this, but I left it in there because I figured we'd end up going over it here. Perimeter is going to have to do with what calculation that we learned that was new. We're going to have to use arc length. Okay, so let's go back and look at that picture and talk about where we would need the arc length at. Okay, so I'm going to erase kind of my mess here. Okay, so I'm just looking at this picture. I do know that this is the function square root of x. I know that this is at 1 and that this is at 4. Okay, the only place I have a curve is right there. Even though it doesn't look very curvy, it's a curve. Everything else are lines. So the only place I need the arc length formula is where the yellow is. Everywhere else I should be able to figure out. Okay, this is a vertical line right here. I know that my x value is 1. How do I get the y value? Or how tall it is? Could I plug it in somewhere? Yeah, I could plug it into the square root of 1. Square root of 1 equals what? 1. So that length of this one is 1. Does that make sense? We hadn't done one like this in class together. Okay. All right, so I'm gonna calculate this one. This one would be square root of 4, which is what? 2. So I know I've got a 1 and I've got a 2. How long is this side right here? How'd you get 3? Yeah, you subtract 4 minus 1 or count, right? All right, so the only part I have to do arc length on is the square root of x. Okay. And we're going to use the advantage of our calculator. All right, so I'll show you. We don't even have to do the derivative of the square root of x by hand. In fact, since it's a calculator problem, I don't want to see you doing that. Okay. Especially because it's named right there too. All right, so let's put that, we're going to put it all together kind of here now. I got to scroll back down to do that. All right, so perimeter. So we're going to say perimeter equals, we said it was 1 plus 2 plus 3 plus the integral from 1 to 4, because that's we're still doing the arc length between those two numbers. Arc length, remember, is square root 1 plus the derivative of f of x. Is it derivative squared? I think it's derivative squared, isn't it? Yeah, derivative squared dx. It's not one that I have as well memorized as some of the others. Okay, let's use our calculator to our advantage right now. Okay, so let's see. We do have our square root of x in there. Okay, I guess I should have used it. Yeah, I think that's square root of x in there, isn't it? Yeah, it is. Okay. All right. So I could probably add 1 plus 2 plus 3 in my head. I'm going to start with 6 plus shift plus, and we're going from 1 to 4, and then square root of 1 plus, and you're going to want to open some parentheses. Now, I need the derivative of f1. Okay, so I'm just going to come over here with the button next to the book. Everybody see where I'm pointing? It's between the 9 and the book. And I'm going to grab that little derivative symbol. And we're just going to type in x. If I can find my x. And then in this one, we're going to put var f1 of x. And then make sure you square the outside. And put an x after the d. And then go ahead and hit enter. It's a complicated one to get in. I would make sure I practice that a couple times on my own. Okay. So whatever it was, 9.617 or 18 or 168. What's wrong? Says it's wrong. What did we get? Oh, maybe I didn't square my answer or something weird. Let's just double check our formula really fast. I want to make sure I did my formula right. It's possible I got the wrong answer in there. Let's see. 813. But I'm pretty sure we had the right one. Okay. Square root of the derivative squared. I might not have squared my derivative when I did it, when I calculated it before. That's probably what happened. Let's see. Or maybe I didn't add 6. Or let's see if I did 6. I got 9. Let's see. I didn't square my derivative. All right. Are there any others that we're struggling with on the review that we need more assistance on? Oh, there's one more. Thank you. Sorry. Whew, almost missed it. All right. Region S is the base of the solid. For this solid, each cross-section perpendicular to the x-axis is a semicircle. So again, we're perpendicular to the x-axis. Right, but do not evaluate the expression that will compute the volume of the solid. So we already talked about the side length being just the square root of x. The side length in a circle is like the diameter of a circle. So I know my area. What's my formula for area of a circle? So I need to know if this is the diameter length, how do I get the radius length? Divide it by 2. Good. All right. Actually, that's the area of a circle. What's the area of a semicircle? Over 2. Okay, so that's what I got to plug into. So this part here is all coefficient. So I'm going to throw coefficient out front from 1 to 4. And then we're going to plop this guy into the radius squared. Again, perfectly good. In fact, I left it like that. That's a miracle. Because I was simplifying everywhere else, wasn't I? I could have also done x over 4 dx. Maybe I put both answers in. I might have. Okay. Is there anything else you guys are concerned about? All right, we have about 10 minutes, 10 to 15 minutes left, right? Second period, 12. Okay, why don't you guys open up the 8.1 Otis and take a minute or a couple of minutes and skim through that, see how you did. I think I've got it open for you to do. While you're doing that, I'll pull it up. And then we can, if we have whatever we have time for, we can go through a few of those, okay?